Hey Scholars, welcome to chapter 21-5. We're looking at how should we deal with now hazardous waste, stuff that could really cause harm to the environment as well as ourselves as far as human health goes. So when we're looking at, we can use integrated management of hazardous waste, just like we use integrated management of municipal solid waste. But the biggest thing with hazardous waste, because it can cause harm to the environment as well as to us, is to produce less of it, to produce products, convert less hazardous, to convert it to less hazardous substances, or rest it in long-term storage. Those are kind of our, in order, are kind of our three hierarchies with dealing with hazardous waste. And the biggest one is just produce less. We can produce products with less hazardous waste, then we're good to go overall. Increased use for post-consumer hazardous waste. So after we're done with the product itself, what can we do with that hazardous waste? After we can separate it, use it for something else. But when we look at it, again, we're looking at the integrated management of that hazardous waste, and we're looking at kind of in a hierarchy system. Producing less is always the first option. Changing our industrial processes, changing our products that will have less harmful chemicals and hazards inside them. We'll also recycle and reuse the hazardous waste in the production as well. Convert to less hazardous or non-hazardous substances that will help with decomposition, incineration, thermal treatment. Those are ways of changing the hazardous material and maybe converting it into maybe less hazardous material. And our last-ditch effort is to put it in a long-term storage, either surface impoundments, underground, inject it far underground, or put it in the landfill. So those are kind of our methods of dealing with hazardous waste overall. Well, we're going back to our case today looking at recycling e-waste, and we figured out that a lot of our developed countries, e-waste, electronic waste, goes to China. Actually, 70% of it does, which they're already in hazardous working conditions, so it is not necessarily the best method of dealing with our e-waste, that's for sure. And we need to reduce our toxic components in electronics. That would help out tremendously in dealing with that, because they are very, very hard to recycle as far as the computers and electronics that we have today. In 2008, the Basel Action Network was thought up, and it basically is a way of looking at people who are good e-stewards, especially companies that are they basically certify companies in order to say that, hey, these guys are dealing with e-waste properly in our own country and doing it in a very 21st century style instead of going back to 17th century style that they're doing in China. So one of the websites you can go to is ban.org/pledge1, and it kind of brings you to a website that shows you some of those certified places. There's another website called phonesforcharity.org. If I don't know if a lot of you have old cell phones that you still have sitting around the house somewhere, you can donate those to that website. And that is a good thing as well. So those are a couple of different websites to check out if you're interested or getting rid of some of your e-waste. Those are a couple of good ones to go to. Let's take a look at how can we detoxify or make those hazardous wastes less toxic overall. We got to collect them and then detoxify them, and there's a couple of different methods we can use. And the first one is physical methods, literally filtering out the hazardous material using charcoal, resins, filters, things like that. The second one is chemical methods, like using chemical reactions in order to get the the output or the product of the reaction to be less hazardous overall. Like in this case, cyclodextrin. It removes toxic materials from pesticides while they're in the groundwater or in the soil. So that's one method of kind of making it less toxic. Another way is using nanomagnets, actually tiny particles coated with different substances to help them absorb whatever toxin you're trying to extract. In this case, there's an example of kerosene, and we're looking at extracting oil, and that's a way of doing that. Bioremediation is another one. It's application of bacteria or different enzymes that basically biologically, naturally break down toxins themselves. Another one is called phytoremediation, by using genetically engineered plants or just plants that normally do this to absorb and hold toxins. The last-ditch efforts of detoxifying are incineration through combustion, because that does release some, and also using a very, very high-temperature plasma arc torch to actually using electrical current to burn at such hot temperatures that there's little to no ash or even pollutants. So those are a couple of different ways of detoxifying hazardous waste. We're going to take a look at this one first. This is phytoremediation, and then we'll look at the pros and cons of each of those. Phytoremediation is basically taking literally plants that are good at absorbing and good at holding on toxins while still surviving. Like in this case, phyto or rhizofiltration, using kind of hydroponics and roots of plants such as sunflowers, dangling roots in the ponds that absorb pollutants, especially radioactive strontium and cesium and different various organic compounds. So that's one that specifies in that type of pollutant. There's other ones like the roots of plant Indian mustard and brake ferns that can absorb toxic metals such as lead, arsenic, and store them in the leaves. Now, we'll talk about some of the pros and cons of this in a second, but the pros is that it's easy to establish. You're planting plants. It's inexpensive. It can reduce material dump into landfills, and it produces little air pollution because you're dealing with plants and they're doing photosynthesis. And low energy use. The problem is it takes a long, long time to get this set up. Several growing seasons, effective only at which the depth of the plant roots can reach. So they can't absorb anything if the toxins below the root line there, they're not going to be doing any help at all. Some toxic organic chemicals may evaporate from plant leaves, so they're just going to the atmosphere through transpiration. And some plants can also become toxic to animals. If those compounds build up in the plants, animals rely on those plants to eat, you can be getting it back into the food chain and really causing a havoc on the food chain. Another one is plasma arc, and some advantages that it's very small, it's easy to move around at different sites, and it produces no ash. You can see it here actually drilling below the ground, and then actually sparking the arc itself, and then causing that stuff to burn, eventually slowly getting smaller and smaller as far as the hill goes. The disadvantage is that it does cost a lot of money. It does produce CO2 or carbon dioxide, can release particulates like chlorine into the air, like chlorine gas and things like that, and also can vaporize and release toxic metals and radioactive elements as well, which can be bad. So those are a few trade-offs for plasma arc systems. Another one is we can store it, forms of it in hazardous waste in long-term storage, and that we can either bury it on land or in the long-term one, which is deep well disposal, like literally depositing liquid hazards that are pumped below the aquifer so they don't leak into the aquifer and cause our groundwater to become contaminated. Although if the well itself gets cracked or anything, it can do that. Surface impoundments would be storing it on land in ponds or pits or lagoons with screen liners that hold the water in as far as evaporates as the water evaporates. And then secure hazardous landfills buried in drums deep within the surface. And again, hopefully those drums last long enough to not leak out into the soil. The trade-offs for deep well disposal are it's a very safe method if the sites are chosen carefully where there's no geological change like earthquakes or things like that. The waste can often be retrieved if there's a problem. It can be just sucked right back up and removed somewhere else. It's easy to do and it's pretty low cost. The problem with it is we can see leaks or spills at the surface coming from corrosion of this well casing here. There's going to be a problem there, which then can escape into the groundwater system, and it's still an output approach, not really trying to prevent the hazardous material at all whatsoever. This is a surface impoundment. It's not actually Niagara Falls, not the beautiful Niagara Falls that you're used to hearing about with the big water itself, but this is an impoundment where they've kept different things and trying to hold them as far as hazardous materials. There's advantages to this. It's low cost. I mean, it can be built really quickly. It's just digging a hole pretty much and lining it with some things. Waste can often be retrieved when necessary. It's right there at the surface and can store waste indefinitely with secure double liners. The problem with it is that you can see if there's leaking liners or no lining at all, that groundwater is going to be contaminated. You're getting air pollution because the VOCs are being released to the atmosphere. If it does flood, like in an area like us in Jacksonville, where we have flooding occurring sometimes because of hurricanes, it can leach out and get into the groundwater, which you can see here. If it's disruption and leakage from earthquakes or things like that, and again, it's an output approach. Those are some negatives there. All right, this is looking at securing it long-term hazardous waste landfill, where you can see all the hazardous waste is stored in drums and then buried in an impervious clay or concrete kind of container. And then there's obviously earth below that, and then groundwaters. So it is buried above the groundwater, which could be dangerous if this thing did leak, although there is a leak detection system and groundwater monitoring as well. So leak detection, groundwater monitoring, and there's obviously a layer of earth over top of it so you can't see it. There's pros and cons to that too, but that's really the last ditch ever. You really are never going to try to get down there and touch that again as long as it doesn't leak. So what can you do about hazardous waste? Avoid using pesticides, other hazardous chemicals, or use them in very small dosages. Use less harmful substances for commercial chemicals and for most household cleaners. For example, use vinegar to polish metals instead of the stuff that you buy from the store. Use baking soda to clean household utensils. Borax to remove stains, things like that, instead of using high intensive and different chemical-based substances. Do not dispose of pesticides, paint solvents, antifreezes, other hazardous chemicals by flushing them in the toilet or pouring them into the ground naturally. It does not break down very easily whatsoever. So let's see what the government has kind of helped us do with hazardous waste regulations in the U.S. It started back in 1976 with the Resource Conservation Recovery Act, or the RCRA. But the problem with the Resource Conservation Recovery Act, and at least the government was trying to do, it was a good start to kind of helping to identify hazardous waste and maintain that that different businesses and companies were allowed to produce some of them, but only on a very regulatory scale, and kind of using permit holders had to use a cradle-to-grave service to deal with it. But only really encompassed 5% of the hazardous and toxic waste on the planet. So not a very, very strong act, even though it was a good start to trying to deal with hazardous waste. 1980, we had the Comprehensive Environmental Compensation and Liability Act, or CERCLA, as I like to call it, and otherwise known as AKA Superfund. It's basically what they did was they found where hazardous waste have really, really contaminated the environment and done major damage to the environment, and on a priority basis cleaned it up. But the problem with it is that it says in this is going all the way back to 1980. The EPA has dealt with over 1,500 Superfund sites. So far, only 321 of them have been cleaned up and removed from the Superfund list. In '84, Congress amended the Superfund Act, or the CERCLA, to give citizens the right to know what toxic chemicals are actually being stored or released in their communities. We kind of looked at that earlier in this semester when we looked at kind of the hazardous materials in the human health section. But there's another government website you can go to. It's called www.epa.gov/tri, TRI, and then another backslash there. And if you go to that, you can look up our county and even find out where all the hazardous material is located and what's producing it. Another part of it, it says in 2008 there were about 1,240 sites on the list. The Waste Management Research Institute estimated that 10,000 sites should actually be on the priority list, but it would cost about $1.7 trillion. And the problem with it is it costs so much money to clean up this output approach that Superfund's broke. The pace is slowed in cleanup because their money is just not there. It's running out. There have been some laws in Congress, and several state legislatures have actually encouraged the cleanup of brownfields, which are just old abandoned industrial and commercial factories and sites like that, junkyards, landfills, gas stations. And actually brownfields can be cleaned up and reborn as natural parks, natural nature reserves, parks, athletic fields, eco-industrial parks, and also neighborhoods. And by 2008, because of this legislation, more than 42,000 former brownfield sites have actually been redeveloped in the United States, which is a good thing. So we got a long way to go with dealing with hazardous materials, especially the cleanup of them since we used them for such a long time, but we're making some headway. The biggest issue that we have now is building materials, electronics specifically, that are hazardous material free and having to deal with that. But next time, we'll see you guys next time when we look at how to make the transition to a more low sustainable waste society. We'll see you guys next time.